So this is lesson 9, polynomials, adding and subtracting polynomials. The definition for polynomial is a finite sum of terms of the form a x to the n. And all that means is a is going to be a number, a real number, which are the only numbers you know as of this point. X would be a variable, and n would be a whole number, meaning it has to be positive. And this simply means finite, means it doesn't end. You could have 1, you could have 2, you could have 100, you could have 1,000. Adding terms of the form that look like this. So all that means is that you're going to add terms, and then we're going to put examples of terms right here. So 2x to the 5th, that's a term. -3 could be in front, as long as this is a real number, and then the exponent has to be a whole number. The variable could be y. It may just be y to the 3rd power. 3y to the 2nd power. -4x. -5. These are all called terms. You could even have AB, that's a term. 2AB. Okay. So the degree of a term in one variable is the same as the exponent of the variable. So what is the degree of 5x squared? You see the exponent here, so it is 2nd degree. What is the degree of this one? This is a 1, so it is a 1st degree. The degree of a polynomial is the greatest or largest degree of any term of the polynomial. So here we look at this. This term is a 5th degree. This term is a 4th degree. This term is a 3rd degree. This term 2. This term 1st. So since 5 is the highest, the greatest degree, this would be a 5th degree polynomial. This has a degree of 1. This has a degree of 2. This one has a degree of 3. This one has a degree of 4. So the degree of the polynomial would be 4th degree. If you have any questions on this, just write them down and we'll talk about them tomorrow night or on the next class. So, types of polynomials. Types of polynomials, the number of terms, there's only one term, there's only one thing, nothing added to it, so one term. And we call this a monomial. Mono means one, so we call it a monomial. Notice we have two terms, 1, 2. So two terms, we call this a binomial. Like bicycle with two tires, bi means two. So here we have three things that are separated by plus and minus signs. So 1, 2, 3, that's three terms. So this is a trinomial, like tricycle. Trinomial. Tri meaning three. This next one, we've done problems like this. We're just going to take -2 and put it in place of x. But we have to be careful. We put our parenthesis for our x and the squared goes outside. Parenthesis for x. And then we're going to take -2 and put it inside here. And we learned that this was -2 times -2, which would make +4. Remember, we're following PEMDAS. So parentheses, we don't have any. Exponents would be this. So we write everything else down. Then no more parentheses, no more exponents. Multiply or divide. Nope. Oh, there's a multiply. So we have to do one step at a time. So that becomes +10. Now no more parentheses, no more exponents, no more multiply, divide. Can we add, subtract? Yes. We're going to add 4 plus 10. We get 14. So that becomes 14. Oops, that's not going to do us any good. That becomes 14 plus 4, which becomes 18. Okay, this, excuse me, this is just like the problem that we just did right here. The difference is, I don't know if you can see me, is just like this problem right here. The difference between this one and this one is that we're going to have to put in 3 different y values. So it's just a long process. We just have to put this into for x. So 2x minus x to the third. We're going to do -3 first. So 2 times -3 minus, don't forget parentheses, exponent on the outside, -3. So that's -6 minus -3 to the third power is 27. Now, I did my multiplying first because I knew it wouldn't affect my exponents. If we were following PEMDAS, we should have left this alone and got this as -27, which becomes +27, because a net minus a negative would be a positive. Then no more exponents. Then we can multiply. and then we can put together and add. So this is 19. So we can see this would have become 19 as well. Alright, so I'm going to erase this one. Now let's do 1. So y equals 2x minus x to the third. And we're going to use x equal to 1. So we're going to put a 1 right there and a 1 right there. Exponents first, so we leave this alone. And that gives us 1. Multiply or divide. So 2 minus 1. And then add or subtract. So when x is 1, y is 1. So now I'm going to put 5 in. So y equals 2 times x minus x to the third power. Let me draw a line through here so you know where I'm working. So we're going to put 5 in. There's 5, there's 5. Exponents comes first, so we'll leave this alone. 5 to the third power is 125, I believe. And then multiply, divide, so multiply. And then add or subtract gives us negative 115. So when x equals 5, for this function, y would equal negative 100, and that's a 5. Okay. So I'm going to do this one last problem, and then I'm going to leave the rest to do in class. So this is of our polynomial, just like we've been working with. It says it models the number of computers sold X years after 1997. So they want to know in 2003 how many computers were sold. So we have to first say X is going to equal 2003 minus 1997. And that gives us 6. So at 2003 would be x equals 6. So we're going to take it and plug it in. Remember to put the square on the outside. And we're going to take 6 and put it in place of x. So this can be entered straight in your calculator exactly like it's written, and we find that it equals, I did not write it down. So you can multiply it out and see what it equals. And we will talk about it in class. My time is just about up. We will finish the rest of these problems in class. Don't worry about doing them now. I will see you next class.